Hello everyone, my name is Nigar Ahmadova and welcome to this online physics class. In today's lesson, I will be walking you through 15 multiple choice questions from past papers. These questions will help you prepare for upcoming exams. If anything is unclear or if you have any questions during the lesson, feel free to leave a comment and I will be happy to help clarify. Let's get started. Question number 1. A student wishes to measure accurately the volume of approximately 40 cubic centimeter of the water. She has two measuring cylinders, a larger one that can hold 100 cubic centimeter and a smaller one that can hold 50 centimeters cube. The water forms a meniscus where it touches the glass. This is meniscus, guys. This is meniscus. Which cylinder and which water level does the student use to ensure an accurate result? Dear students, the smaller cylinder allows the student to measure more precisely because the scale markings on the cylinder will be closer together, so it will give finer resolution. So, answer is either C or D. What about water level? We have to take water level from bottom of meniscus. Bottom of meniscus means that you have to take reading from here. So, the answer is C. Let's move on to the question number 2. An astronaut of mass 80 kg is standing on a planet with gravitational field strength which is equal to 3.8 newtons per kilogram. What is the weight of astronaut on this planet? First of all, let's write formula for weight, which is equal to mg. And mass of astronaut is 80 kg. Gravitational field strength is given, which is 3.8 newtons per kilogram. When we calculate, we get 304 newtons. Whether you round to the nearest 10 or 100, the result would be 300 newtons. So the answer is B. Question number 3. The motion of an object is represented by the speed-time graph shown. Which quantity is equal to the area under the graph? As we know, the area on the speed-time graph gives the distance traveled by the object. So the answer is C. It means that if we want to calculate distance traveled, we need to calculate area of this trapezium. Question number 4. A sealed container of volume 2000 cubic centimeter contains air at high pressure. The container is placed on a top pan balance. The balance reads 200 grams. All the air is removed by a vacuum pump and the balance reading changed to 196 grams. What was the density of the pressurized air? Let's remember formula for density. Density is equal to mass divided by volume. Now, let's find the mass of the air. The balance reads 200 grams when container is filled with pressurized air. After the air removed, the balance reads 196 grams, which is the mass of empty container. So, to find the mass of pressurized air, we need to subtract 200 minus 196, which is 4 grams. This is mass of pressurized air. And the volume of the air is given 2000 cubic centimeter. Now we can calculate density. Density is equal to 4 grams divided by 2000 centimeters cube, which is equal to 0.002 gram per centimeters cube. So the answer is A. Let's move on to the question number 5. An object of mass 0.8 kilogram is moving in a straight line at a velocity of 2 meters per second. A force is exerted on the object in the direction of motion for a period of 1 minute, and the velocity of the object increases to 6 meters per second. What force is exerted on the object? To calculate the force exerted on object, we need to use Newton's second law of motion, which is resultant force is equal to mass multiplied by acceleration. Let's remember formula for acceleration. Acceleration is rate of change of velocity. So acceleration is v minus u divided by time. Let's substitute this formula in the first formula. M multiplied by v minus u divided by time. Now, let's substitute the known values. Mass is given 0.8 kilogram. Final velocity is 6 meters per second. Initial velocity is 2 meters per second. And time is 1 minute. First of all, we have to convert 1 minute to the SI unit, 60 seconds. After calculating, we will get 0.0533 newtons. So the answer is A, guys. Question number 6. A gymnast jumps down from a high piece of apparatus. She gradually bends her knees as she lands. Which effect does this have? Dear students, let's analyze each option. She will have a smaller change of momentum as she lands. This is incorrect, because the change in momentum is determined by the gymnast's velocity when she hits the ground and her final velocity, which is 0 when she stops. So the change in momentum is the same regardless of how she lands. Option B, she will lose less kinetic energy as she lands. It's also incorrect, because the loss of kinetic energy when she lands depends on her jump height and speed. Bending her knees doesn't affect how much kinetic energy is lost. Let's look at variant C. She will exert a smaller impulse on the ground as she lands. This is also incorrect, because impulse Ft is equal to change in momentum. We said that change in momentum is the same, so impulse remains the same. However, bending the knees spreads the force over a long period of time. Let's look at variant D. She will experience a smaller force from the ground as she lands. This is correct, because from this equation, force is equal to change in momentum divided by time. When the gymnast bends her knees, she increases the time over which her momentum is brought to 0, which reduces when the time increases. Average force is reduced. That's why the answer is D. Question number 7. The table gives 4 energy resources and states whether the main source of energy for the resource is the sun. Which row is correct? Generally, most of the Earth's energy resources ultimately derive from the sun, either directly or indirectly. However, there are a few exceptions, which are geothermal energy and nuclear energy. Geothermal energy resource and nuclear energy resource don't derive their energy from the sun, because geothermal energy comes from the heat stored in the Earth's core, which is a result of the planet's internal heat flow. So, geothermal, main source of energy, sun, no, A is incorrect. But nuclear energy also is not derived from the sun, because nucleus of heavy atom splits and releases energy. The energy released in nuclear fission is not derived from the sun, but from the natural radioactive decay of elements. For most other energy resources, such as fossil fuels, coal, oil, natural gas, wind, hydropower, biomass, the energy ultimately traces back to the sun. So the answer is C. Water held behind the dam, hydroelectric power stations, they derive the energy from the sun. Yes, the answer is C. The next question, which is question number 8. The equation ρgh can be used for a liquid. What is meaning of the term rho? This equation is used to calculate pressure in liquid. And here, rho, which is Greek letter, represents density of liquid. Answer is B, the easiest question. Question number 9. What are the correct terms for each change of state? When water, a liquid, is cooled below its freezing point, it changes into ice, a solid. So liquid to solid is solidification. Answer either A or C. But when the water is heated to its boiling point, it changes from a liquid to gas. An example of a liquid to gas transition is evaporation or boiling. Evaporation. So 9 is C. Question number 10. Extremely small pollen grains in water are viewed through a microscope. The grains are seen to move continually and randomly. What is the reason for this random movement? The random movement of the pollen grains in water is due to Brownian motion. Brownian motion. This movement happens because the particles are constantly being bombarded by the molecules of surrounding fluid, in this case, water molecules. So, the answer is A. The grains are moved by randomly moving water molecules. Water molecules are in constant motion due to their thermal energy. Even though these molecules are too small to see, they collide with the pollen grains in all directions, causing the grains to move in an unpredictable, random manner, as you see in this figure. The next question, which is question number 11, graph shows how the volume of a fixed mass of gas at constant temperature varies with its pressure. So the relationship between volume of a fixed mass of gas and its pressure at constant temperature is described by Boyle's law. Boyle's law states that pressure and volume are inversely proportional at constant temperature. So, the graph that shows how the volume varies with its pressure at constant temperature would be a hyperbolic curve that decreases as the pressure increases. Volume decreases as pressure increases. So the answer is D. Let's move on to the question number 12. Which effect is caused by thermal expansion? Guys, thermal expansion refers to the tendency of materials to expand when heated and contract when cooled. This happens because the particles in the material move faster and spread apart when they gain heat, causing the material to expand. And the best example of the thermal expansion is a railway track buckling on a hot day. As the temperature rises, the metal of the tracks expands, and if the tracks are fixed at certain points, they can bend or buckle. So the answer is C. Question number 13. The temperature of the water at the bottom of waterfall is greater than temperature of water at the top. The energy and gravitational potential store of the water at the top is transferred to the thermal store at the bottom. The specific capacity of water is 4,200 joules per kilogram Celsius degree. What is the temperature difference for a waterfall of height 21 meters? To calculate the temperature difference of water as it falls, we can use the principle of energy conservation. And it is given that the gravitational potential energy lost by the water as it falls is transferred to the thermal energy of the water. It is given. So, we can calculate gravitational potential energy lost by the water mgh, and the thermal energy gained by water can be calculated by Cm delta T. Let's equalize these two formulas. In this case, let's cancel out mass from both sides. So we have GH is equal to C delta T, and delta T is equal to GH over C. G is 9.8 on the Earth. Height is given 21 meters. Specific capacity is given 4,200. And the answer is 0.049 Celsius degree. It is B. Question number 14. In which type of wave is the direction of vibration parallel to the direction of travel? Dear students, we call this type of wave longitudinal wave. And all electromagnetic waves are transverse. Primary waves are longitudinal waves. Secondary waves are transverse waves. And water waves are an example of waves that involve a combination of both longitudinal and transverse motion. So the answer is B. And the last question, 15, is about refraction of light. The diagram shows a ray of light passing from air into a diamond. What is the refractive index of the diamond? Let's remember the formula for refractive index. N is equal to sine I over sine R. Here, I is angle of incidence, R is angle of refraction. Let's find out angle of incidence and angle of refraction from the figure. First of all, we have to draw normal because angle of incidence is the angle between normal and incident ray, which is 30 degrees. And the angle of refraction is the angle between normal and refracted ray, which is 12 degrees. So, sine 30 over sine 12, which is equal to 2.4. So the answer is C. This is the end of lesson. See you next time.